Great, thank you very much, everyone, and thanks to the organizers for having me and to the audience for your attention. It's an honor to be here today. As you heard from Granger Morgan, nuclear energy is declining in the U.S., and his assessment is that under current conditions, nuclear will not provide a substantial portion of future U.S. energy supply in the near term. I agree with him, but I also believe that conditions can change, and that in this case they must. The role of nuclear energy in the U.S. is an uncertain one going forward, but its past and current role has heft and importance. Nuclear provides about 20% of U.S. electricity and about 60% of our non-emitting generation. However, nearly 5 gigawatts have retired early in the past several years, closing before their operating licenses expired, predominantly for economic reasons. Another 11 gigawatts have announced early retirement, and 6 gigawatts have warned they may close. So those 28 gigawatts of the most at-risk and recently retired nuclear plants represent as much generation as 70% of total U.S. solar and wind generation. In the PJM interconnect just north of here, 4 plants have announced their impending retirement, and those plants generate 1/3 more power than all of the solar and wind in PJM. This is not to diminish solar and wind, but only to provide context about the scale of the loss of those nuclear plants. Without a change in market signals, these will be the canaries in the coal mine. At least half of the U.S. fleet is considered in danger by some of the analysts, and these plants are not inoperable. They are unable to compete effectively in today's markets with the historically low natural gas prices and also some of the other factors that Dr. O'Sullivan just described. So what does losing 30 gigawatts of the existing fleet look like? If it's replaced by existing sources, power sector CO2 emissions will rise by about 9% immediately. If it's replaced by natural gas, that goes down to a 5% rise in CO2 emissions. Replacing it with solar and wind is also an option, but that comes with a subsidy cost of almost $9 billion per year, compared with $3 billion or less to support the continued operation of the existing nuclear plants. So the decision to support existing nuclear plants should be a straightforward one. It's good for grid resilience and the environment. Nuclear plants support local communities as important economic engines and taxpayers, and the nuclear industry contributes to our national security in a number of important ways. We're seeing positive policy progress in a number of states. New Jersey, New York, and Illinois have all taken action to keep their nuclear plants operating. But looking to the future, the existing nuclear industry is a crucial part of the pathway to bringing the next generation of nuclear technology to market. And we are going to need the next generation of nuclear to meet future energy demand. While we're seeing decreasing demand in the US and Europe, much of the rest of the world is projected to expand their energy use dramatically. Primary energy use is projected to grow more than 50% in the Middle East by 2040, to more than double in Africa, and to grow almost 140% in India. All of those regions are pursuing or considering nuclear energy, and there are a lot of reasons that a new generation of nuclear would be more suitable for them and more sustainable. Advanced nuclear energy is a growing sector of dozens of fission and fusion startups and established firms, billions of dollars of private and public investment, and many hundreds of people pursuing the commercialization of technologies that better address market needs. They are working to increase manufacturing and ship-to-site designs, building smaller units with lower financial risk that would enable incremental additions, increased flexibility, and the use on smaller grids. They are focused on designing for load following and load switching to complement renewable and intermittent resources, and developing microreactors for remote locations, military power needs, or data centers, as illustrated in this image here. These technologies use passive and inherent safety strategies for increased resilience and have a lower waste profile and the potential for fuel recycling. Perhaps most importantly, advanced nuclear holds the promise of competing in U.S. markets and others across the globe. A detailed cost survey of advanced reactor companies showed an average levelized cost of about $60 per megawatt hour, much lower than the roughly 100 megawatt hours or more for a new large light water reactor. But will the U.S. be a leader in advanced nuclear technology? We have a lot of important advantages. We have the most innovative companies and investors, the preeminent nuclear laboratories, a capable and experienced regulator, and valuable data from historic advanced reactor operations. But we also face a slew of challenges. We have a weak domestic market demand, as we've heard, an extremely slow product development cycle, minimal deployment incentives, little recent experience, a weak supply chain that has suffered from decades without new builds, limited government support, and an R&D program that has lacked focus over the past several decades. We are also starting in many ways from behind. China, Russia, and India are all putting steel in the ground, and overseas nuclear industries are largely state-sponsored and have a competitive advantage because of the priority that their governments put on exporting nuclear technology. We will not become leaders by outpacing the Chinese at building or by backing our industry as the Russians do theirs, though we will need to do more in both of those areas. Our biggest competitive advantage is in developing the boldest and the smartest technology, and that is what we need to do to make nuclear energy of the future scalable, competitive, and effective in the global quest for energy that is both abundant enough to power economic growth and development and clean enough to preserve the Earth. So why should this matter to the scientific community? Well, particularly here at the center of American politics, you might recognize the familiar problem. Nuclear energy has been unfavorably politicized, much like vaccines and GMOs. And it's important that we have a clear-eyed reassessment of nuclear as a tool in the transition to clean energy. The scientific community has an important role to play in that assessment. Existing nuclear is the foundation of our low-emission energy portfolio and should be valued for its low-emission attributes. And we can all play a role in understanding and communicating that role. And advanced nuclear can partner with renewables and is suitable for a variety of applications, including powering remote communities, supporting desalination, and providing heat for industry. These are in addition to its potential to provide clean, abundant power to expanding economies. But a U.S. role requires a sustained, robust, and coherent R&D program in conjunction with other supportive policies. I hope this has been of some interest to you. I'd be happy to discuss this in more detail, so please feel free to contact me, and I look forward to the discussion. Thank you.